Lesson 10-2b, equations of transformations of quadratic functions. To write the equation of a transform quadratic function, we need to identify the type of transformation being used. Then identify the value that has been added to, subtracted from, or multiplied by the parent function. And for a quadratic, the parent function is f of x equaling x squared. So first example, use the graph of the function to identify the transformation, then write an equation for the function. So you can see here's the parent function. The vertex moved to the right, and it moved 1, 2, 3, 4, 5 spaces to the right. And remember our formats, f of x equaling x minus h squared plus k. It didn't go up anywhere, so we would have a plus 0. It went to the right 5. That means there would be minus 5. The dilation, there is no dilation because it stayed the same at 1. So we would say g of x is equal to x minus 5 squared. The transformation would have been a horizontal translation, or went right 5. Next, use the graph of the function to identify the transformation here. So again, it still just moved left. So this moved left 1, 2, 3, 4. So let's say left 4. It's still only 1 away on each side, so there is no dilation here. So this would be g of x equaling x plus 4 squared. It didn't go up or down, so we would have our equation being g of x equaling x plus 4 squared. Another one, use the graph of the function to identify the transformation here. So this one, there's a reflection going on, and it's reflecting over the x-axis. It did not shift, but there is a dilation happening. This would be, we could say this would be a vertical stretch. You could also say this could be a horizontal compression as well, because both of them would look the same. Now to find since the vertex didn't move, there is no h or k involved with it, but there is an a involved. So if I'm going to use y for g of x. So y equals a times x squared. I need to choose an x and y variable on here, but we cannot use the one that's the vertex. So here I'm going to choose this point right here, which that is 1 and 1, 2, 3, 4, negative 4. So if I were to put those numbers in, I have a, my x is 1, and my y is negative 4. 1 squared is 1. 1 times a is a. So a is negative 4. So I could have this be g of x equaling negative 4 x squared, or I could do g of x equaling a negative and then 4 x and then the square on the outside. Either one would be, actually I wouldn't put the 4 in here. I would have to do 2, because then that would still make it negative 4x squared. Those are your two ways of writing your equation. Next, example 2, given that g of x is a transformation of f of x equaling x squared, identify the transformation and use the table to write an equation for g of x. I think it might be easier to write the graph first, write the equation first to determine the transformation on that. So first off, we know it has to be g of x equaling a times x squared. We know that there's a compression because your g of x did change, and it's by a product each time. So now if I choose an x and y, I'm going to choose this first one right here. So g of x is -4. Your x here, this is really going to be your f of x squared. Or not squared, but whatever your f of x is, that's going to be your x coordinate. So I need my a, and then my f of x, according to that, was 16. To find my a, I just divide by 16 on both sides, and a would equal a -1/4. So now if I write my equation, g of x equals a -1/4, and then I have my x squared. Now I can see if that makes sense by plugging in numbers in here. So if x is -4, if I have -1/4, and if I put -4 here and I square it, -4 squared is 16. 16 times a -1/4 is -4, and that's what we had here. So our equation would be g of x equaling -1/4 x squared. And our last one here. We can see that it is a quadratic, and then here, if I multiply this by -3, this times -3, this times -3, and this times, this would be a -6. We know that they're multiplying that by a -3 at some point. So to find the transformation on this one, we're going to do g of x equaling a times whatever f of x is. Now if I choose a point, I'm going to choose this point right here. So g of x is -12 equaling our a times -2. Or not -2, our f of x is 4. So then I divide by 4 on both sides. A would equal a -3. And now I can write my equation, which would be g of x equaling -3 times x squared. And to test this out, g of x would equal, if I put -3 in, my x is 2 squared. 2 squared is 4. 4 times -3 is -12. So this one works here. Now the transformation here, this would be vertical stretch, because it's on the outside of the parentheses and the absolute value is bigger than 1. Then this be reflect over the x-axis. And going back to the previous one here, didn't do the transformation. This one would also be vertical, but this would be compression. And there's a reflection over the x-axis. So those are problems for equations of transformations of quadratic functions.